everybody, welcome back to Trial and Error. It's been a bit of a couple of month hiatus here for me in making videos, but I've been busy doing a ton of work outside. Not really worth filming, it's just tractor stuff. But at any rate, I think we got enough months under our belt here, a little bit of winter and a lot of the summer, that I can talk confidently about how this solar thing has worked out for me. And I'll share my opinion on that. We'll share you the numbers on it as well so that you can see exactly where we're at. And then as you see, I've got some extra stuff here because we're going to be doing some additional capacity upgrades on this system, which I kind of thought we were going to have to do anyway. But 4 trailers that I bought at auction, that was enough of a project in itself to do all in one shot. So we're going to be adding another at least 12 panels, another charge controller, and then keeping everything else the same. We're just going to up the sun capacity that it does need as we get into the summer here, and I'm running a lot of air conditioning. Okay, before we get into adding this additional circuit onto the solar panels, I think this is a good time to recap where we are at with this solar project. How did it work out? Was it worth the investment and all of that? So those who've been around, you know, I ended up picking up 4 trailers at auction for DC solar equipment. At that company collapsed, and I knew nothing about solar at all, but it just looked like a lot of good equipment on those trailers. So I thought if I could get a good deal on them, I mean, how can I go wrong? Ended up buying 4 trailers, spent $33,000 including auction fees, but I was pretty confident that I should be able to at least make back most of that money in the parts that I didn't need, like the trailers themselves, the steel, what else? The generators, that was a huge part of it. But obviously taking a bit of a gamble here. I didn't know if it was going to pay off, but now I can tell you it most definitely paid off. So first step was getting all that equipment back to the house and then getting everything disassembled, which was a lot of work. Then I had to begin to design the new system that would take care of my house. So I picked the equipment I wanted, started getting all of that stuff mounted. Then we moved on to getting the panels up on the roof, not wanting to pay for the aluminum, the really expensive brackets. I ended up doing a super strut, and the videos on my channel for all of this stuff. It's just look under the solar playlist. Then we knew we had to cut down some trees. Ended up cutting down a lot more trees than I thought I was going to need to, but that's okay. That all came down as well, and now we are left with a fully functioning system. Let's crunch the numbers here. So the total cost of trailers with the auction fee came to $33,581.15. Now I'm going to go through each of the parts that I knew I was going to sell and how much I thought I would sell them for when I was doing my initial math before buying the towers, and then I'll tell you what I actually made in selling them. So first is the LEDs. So though I had 32 of those that I planned to sell, I was keeping 4 of them, and I thought I would get about $2,240 for those. I actually only made $880 off of all 32 of those. The aluminum towers, there were 8 of those towers that cranked up that had the lights attached to them. I only expected to get about $2,000 for those. I ended up getting $5,200 for those. I sold them to a company that monitors air quality, and they put their sensors on them, and I don't know, but whatever. I made $5,200 off of that, so that was a huge boost. I knew I'd really be making my money on those generators, and I did. So I plan to sell all 4 of those, figuring about $5,000 a piece, so a total of $20,000. I ended up getting $24,200 for just the generators without the fuel tanks. The batteries, I sold 3 of those off, and I plan to get $2,250 out of them. I actually got $2,540, so pretty close there. Trailers, plan to sell all 4 of those as just flatbeds. I expected $8,800 out of those. I actually got $9,499. The fuel tanks, I had 4 of those as well. I thought I would sell them for about $100 a pop, and that's exactly what it ended up being. Inverters, I had 4 of those to sell. Figure those forward bring about $6,000. They brought $6,300. And then equipment cases, so the big aluminum double door cases, I had 4 of those to sell for, I figured, $100. And actually I couldn't even get that. I only got $300 out of them, but that's fine. Sold some battery cables and connectors, just little stuff, bits and pieces, more to help people out than to make any profit on it. And at the end of the day, the grand total for what we sold, and that's after keeping a ton of equipment, came to $49,384. Meaning our total profit was $15,802.85 plus all of the equipment that you guys see that I was able to keep. So how's this thing been running? Obviously one of my primary fears was reliability. This is powering the whole house with really no backup. So this system has to work all the time, 24/7. And I'm happy to say it's actually been really solid. Initially I had some problems and they were all setting related. So it was just a matter of getting those right. And then once we got that right, I probably went for a week of, wake up in the middle of the night and the power's off. You're like, come down, figure out what setting caused it, something tripped something, and the safety thing shuts it down, and whatever. That's all been, knock on wood, very stable ever since then. I did have one problem about a month and a half ago, and everything worked the way it was supposed to work, and it protected itself. But I'll show you what happened. It all started with this little guy. You see this little guy? You should worry about that little guy, because it was on fire. Pretty good, too. This is an 8-gauge cable. This is what was on the output side of the charge controller, so putting 48 volts DC back into the battery bank. And as you can see, she got a little crispy. And these were the two breakers. This was the actual breaker that wire was connected to, and this is the one that was near. I replaced this there's really no damage to this other than cosmetic, but I replaced it anyway just because it got a lot of heat in there. So the reason that went wrong, and actually, if you go by the wire sizing guides, the 8-gauge should have been fine. What the sizing guide doesn't take into consideration is heat buildup. And a lot of heat builds up in these boxes when everything's humming, because you've got the high voltage AC coming in off the roof, along with the DC flowing back through breakers to protect it, and it started getting warm in there. There was metal covers on these. As you can see, I've removed those because really they don't need to be there, and they just help to retain heat even more. So I did a couple things. We removed the covers from that, replaced the breakers obviously that were potentially damaged, and then I went and upgraded all of the output cables to 4-gauge, which is twice the diameter. And then since then I've been monitoring it with a laser temperature meter, and everything's been nice and cool. It runs, at worst case, it's about 10 degrees above ambient room temperature, which is not an issue whatsoever. So that did have to get upgraded. So obviously with the new system, I've got the same 4-gauge output cable on this, just to be safe. And at the end of the day, the breakers did what they were supposed to do. Heat built up. As temperatures increase in electrical anythings, so does the resistance of that connection. So it's kind of a self-fulfilling prophecy of fire eventually making its way there. But the breakers did trip because of that increased resistance, and it prevented anything from getting out of control. All contained in the metal box. Still have a garage left, so that's good. So for the last 6 months, I've been looking for deals on panels, just checking Facebook Marketplace and Craigslist to find some takeoff panels with not a lot of use on them that were a really good deal. And it's hard to find them, but if you wait long enough, 6 months, eventually you'll find a good deal. So these are 72 panel whatevers, which are larger, physically larger than what I have on the roof right now, which is not ideal, just because the lines won't line up going this way. But at the same time, you can't see my panels from anywhere unless you're flying over it, so it really doesn't make a difference. But they're 350 watt panels, and they've only got maybe a year or two of use on them. They're in really nice shape, basically like brand new. And I was able to get these guys for 110 bucks a piece, which is stupid inexpensive for a 350 watt panel. New, you're spending about 400 bucks a panel for something like that. So this was a really, really good deal. Now, I have 4 Midnight controllers. These are 150s, and technically by the math, I could put those 12 panels and spread them out over these 4, and we would still be okay. But when it comes to charge controllers, the lower you can keep things, the more efficient they are at operating. So I thought it was a good idea to invest the 600 bucks or so in another controller. So we have that here, and that is just going to improve efficiency. It keeps these things out of the dangerous heat range, which shortens their life anyway. I think it was probably a good move. But yes, you could technically, I forget, we're going to end up with like 16,000 kilowatts of solar power, or 17,000. We're going to be somewhere in that range. And you could technically spread it if you balanced it just right on all 4 of these, but you'd end up getting into what they call hyper VOC, and just generates a lot of heat and they lose efficiency. So I thought, probably a good idea. Spend 600 bucks. We're already up, as you saw from the value kind of summary here. We're up in cash already on the system. So I've got money to spend that really is free money. So we did that. Grabbed some, I think this is 4 AWG pure copper. Some nice cable to come down from the roof on that on. And then I found this is a used box. I think it's probably off of one of the trailers that somebody's parting out. I was able to get that for 100 bucks. And the only other problem we have now is real estate. So it is getting really tight over here because I really didn't plan for a 5th controller. I did plan to add panels, but I didn't plan for a 5th controller, and it's tight. So here's what I'm doing. So what I think I'm gonna have to do is I'm gonna move this guy over here, relocate these wires further over. We're gonna put the 5th one in here. It'll just barely fit, and I have to scoot these wires up a little bit to make it clear. The problem though is the battery access for these doors swing this way. As you can see, we're tight already as it is, so that's not gonna work. So I think I'm gonna have to cut off this door, which will be a nightmare. And then I'm gonna put a cut down the middle of it, and we're gonna weld in a couple of hinges here so that this comes up and stacks over like so. So we got one more Midnight Classic. So the retail on these guys is like 800 bucks. You can find them online for about 600 or 6 and change. And you know what, there's way cheaper controllers out there. There's a ton of stuff coming out of China that is cheaper per watt hour or amp or however you want to measure it. But there is something to be said for a good American-made controller that is built like a brick shithouse, and these Midnights are just that. Again, there's way prettier options out there with neater interfaces online, and those things are all great. But to me, when it's powering your house, you go with the good stuff. And then the other reason for that is I already had the Midnights, and these all interface together. So in there's one master, and it controls the slaves in terms of charge mode and all of that stuff. And it lets me see all of the data on one interface. So I don't think I would have changed anyway, but there's nothing better than a good quality controller that isn't a knockoff from somebody else's design with sketchy components. So we're gonna stay with them. Again, these guys connect right through to here. We'll mount it just like the existing ones are mounted. So it's configured here for a little bit smaller of a system out of the box. It's set up for 2 different 15 amp feeds coming in. I'm going to jump these together, and it'll treat it as a 30 amp input feed from the PV cables coming down from the ceiling. It's got a 63 amp breaker in it for the DC output. I'm going to up that because we're going to be tickling that 72, 74 amps at 48 volt output, which is a lot of current, and we'll be tripping that if we don't upgrade it. So that'll be getting replaced as well. Then you've got a bus for the DC side negative and a bus for the PV side negative, and those end up getting tied together anyway. First thing, I'm going to cut this door off. I'm going to move the beer out of the way. So before I did anything, I've had a fan going, blowing fresh air through here, and we're also at a time where the batteries aren't really off-gassing. Kind of neutral on power. We're making as much power as we're using, so there's no real load there and creating anything. So I'm going to cut the pin, I think, out of here, and hopefully I can pull it out from that side. Time to do some sketchy shit. Do-da, do-da. Hope I get away with it. Oh-de-do-da-day. Went to the fertility clinic the other day. They asked me if I wanted to masturbate in a cup. I thought to myself, you know, I'm pretty good. I don't know if I'm ready for competition. So we'll get this outlet out and out of the way. Probably just gonna move it for now. Eventually I'll rewire it, shorten the cable, and make it all pretty. But for now, I just need this thing out of the way. I'm enjoying the fan until I do. Should have put the AC on out here earlier. It's been like crazy hot for New Hampshire. We were up over 100 yesterday. It's about 96 right now. Don't work on live outlets. Do as I say, not as I do. So yeah, 100 degrees, and the humidity we get up here, it's not like it is out west. You guys get that 110 degrees, but it's pretty dry. Here, you freaking feel it. All right, so and the funny thing about solar is solar doesn't like heat. I mean, before I knew anything about solar, my first inclination would be, well, yeah, more sun, more hotter, more better. But it's actually, same rules of, or same electrical principles always apply, that heat is never the friend. And the same thing holds true with solar panels. You lose quite a bit of production with every degree over, say 80 or so. It starts a little bit of a down curve there, which again, outward looking in, I would not have expected that. So believe it or not, our peak production for solar is like March. That's when I was kind of getting basically about 20 kilowatt hours per controller back in March. And 20 kilowatt hours times, well, will be 5 controllers now, is a lot of power. I think the average house uses about 30 kilowatt hours a day. So we would power the average house with 1.5 of these, and we're about to have 5. So the screws always go horizontal or parallel with the outlet. If you have them going this way, it'll actually mess up the voltage coming out. So make sure all your screws are turned right. That's not a fact. It's just something I made up. People asked when I was building this why I didn't want to use conduit. And this would be the answer for that. When you run stuff in conduit, though it's nice, since this is all DC stuff, not AC, it doesn't need to be in conduit, first of all. And then second of all, is when I needed to upgrade this cable, it was kind of a non-issue, quick and easy to do. Now we're making some other movements, moving stuff around. If this was all in conduit, that would be a way bigger project than what this is going to be. So, besides the fact that I like the look of Back to the Future, the DeLorean with exposed stuff, I'm kind of going for that look here anyway. The other reason is actually pretty useful. And poof, like magic, it's all set up. So I didn't film the setup on this because it's pretty straightforward, honestly. But we'll get into it now. We have the main feed coming from the panels that I have temporarily set up outside. Coming in here, going through a 63 amp breaker. So right now that's putting, it's 94 volts, a little bit lower voltage on this chain, but much higher amperage. And it's making 3,000 watts right now, which is coming back out as DC current going to the batteries through a 80 amp breaker there, and then through that upgraded cable, which is doing a really nice job of keeping my temperatures down, so that's good. Because it is still 90 degrees outside right now, it is way too hot for me to willingly get up on the roof. I've routed all the wiring where it needs to go, and then it's just coming down here and scooting across the floor over to the temporary panels because I wanted to capture the sun that we're getting now, but like I said, I'm not climbing up on the roof when it's 100 degrees out. That's just not my idea of fun. So we're gonna wait till the fall, and then I'll be able to get those panels mounted just like we had the rest of the panels. But what a difference adding this has made. So I've had this going now, it's been a week since I filmed the first part of this video, and in that week we have not had to use current from the grid at all. This has made up the difference. It's making about 20 kilowatts a day, and that's in the heat. So as we get into the fall, the sun comes down a little lower, but the temperatures drop, so the efficiency goes up. I can see this easily getting 26, 27, maybe 28 kilowatts out of just that one. These guys will average between 17 and 20 kilowatts themselves on a really good day. So as you can see, we've got, you know, between 80 and 100 kilowatts of power coming in on any given day. Now we don't use that much. Most of the time we don't use that much, but there is efficiency lost when you're not feeding directly into your grid and you're going in through a battery pack. You lose some efficiency as it charges through heat in the battery packs, and you lose it when it comes back out again. So you need to over project or over supply when you're off grid, versus if you were just grid feeding and tied in with the grid and getting credit from your grid company. Which I didn't want to go that route because of all the rules that come along with that. So, and I'm still glad I didn't, because now when the power goes out, nothing happens here. We have no idea what the power is doing. It could be out for a week, we'd have no idea. So that's really nice. This is where the panels will sit until the weather kind of breaks here and I can get up on the roof in some level of comfort. But hopefully this video kind of gave you guys an idea how this whole thing worked out. I, again, went into this very blind, just knew that it looked like a good investment, and I'm happy to say it certainly was. I made $15,000 before we even flipped the switch to turn the thing on, and you know, took another, call it a couple grand, 2,500 bucks in additional supplies I had to buy, as well as these panels and this fifth charge controller. So we are still up, and then it's saving me thousands, I mean thousands and thousands of dollars in electricity for the foreseeable future. So appreciate you all watching as always. Any questions, concerns, comments, and or criticisms, throw them down in the comment section below me. Otherwise, everybody, thanks for watching and have a great day.